Introduction of functions in mathematics. Functions are a fundamental concept in mathematics that describe the relationship between inputs and outputs. They are used to model various real-world phenomena and are essential for solving equations, analyzing data, and understanding mathematical patterns. In this comprehensive guide, we will explore the definition, types, properties, and applications of functions in mathematics. Definition of functions. In mathematics, a function is a rule or correspondence that assigns each element in one set, the domain, to exactly one element in another set, the range. This rule specifies how the input values are transformed into output values. Notation of functions. Functions are typically denoted using function notation, which consists of the function name followed by parentheses containing the input variable, s. For example, if f is a function, f, x, represents the output value of the function when the input is x. Types of functions. 1. Linear functions. Linear functions have a constant rate of change and can be represented by a straight line on a graph. They have the form f, x, equals mx plus b, where m is the slope and b is the y-intercept. 2. Quadratic functions. Quadratic functions are second-degree polynomials and have a parabolic shape when graphed. They have the form f, x, equals x caret 2 plus bx plus c, where a, b, and c are constants. 3. Exponential functions. Exponential functions have the form f, x, equals a backslash dot b caret x backslash, where a and b are constants and b is the base of the exponential. 4. Trigonometric functions. Trigonometric functions, such as sine, cosine, and tangent, describe the relationships between the angles and sides of a right triangle. 5. Logarithmic functions. Logarithmic functions are the inverse of exponential functions and have the form f, x, equals log underscore b, x, where b is the base of the logarithm. Properties of functions. 1. Domain and range. The domain of a function is the set of all possible input values for which the function is defined. The range of a function is the set of all possible output values that the function can produce. 2. One-to-one and many-to-one. A function is one-to-one if each input value maps to a unique output value. A function is many-to-one if multiple input values map to the same output value. 3. Even and odd functions. An even function is symmetric about the y-axis, meaning f, x, equals f, x, for all x in the domain. An odd function is symmetric about the origin, meaning f, x, equals f, x, for all x in the domain. 4. Increasing and decreasing functions. A function is increasing if its values increase as the input values increase. A function is decreasing if its values decrease as the input values increase. Applications of functions. 1. Modeling real-world phenomena. Functions are used to model various real-world phenomena, such as population growth, temperature change, and financial trends. 2. Solving equations. Functions are used to solve equations and inequalities by finding the values of the input variable, s, that satisfy the given conditions. 3. Analyzing data. Functions are used to analyze data sets, such as finding the average, median, and standard deviation of a set of values. 4. Optimization. Functions are used in optimization problems to find the maximum or minimum value of a quantity, subject to certain constraints. 5. Engineering and science. Functions are used extensively in engineering and science to describe physical phenomena, design systems, and analyze experimental data. 6. Graphical representation. Functions are often represented graphically, where the input values are plotted on the horizontal axis, x-axis, and the corresponding output values are plotted on the vertical axis, y-axis. The graph of a function provides a visual representation of its behavior and can reveal important characteristics such as symmetry, intercepts, and trends. 7. Composite functions. Composite functions are formed by combining two or more functions. The output of one function becomes the input of another, creating a chain of transformations. Composite functions are denoted by fg, x, where f and g are the component functions. 8. Inverse functions. Inverse functions are functions that undo each other. If f is a function that maps elements from set A to set B, then the inverse function of f, denoted by f(-1), maps elements from set B back to set A. 9. Parametric functions. Parametric functions describe the motion of an object using parameters such as time. They are often used in physics and engineering to model trajectories, curves, and other dynamic systems. 10. Piecewise functions. Piecewise functions are defined by different rules for different parts of their domain. They are typically used to model situations where different conditions apply in different regions. 11. Functions in calculus. Functions play a central role in calculus, where they are used to study rates of change, slopes of curves, and areas under curves. Derivatives and integrals are fundamental concepts in calculus that are based on the concept of functions. 12. Functions in computer science. In computer science, functions are used to encapsulate reusable blocks of code that perform specific tasks. They help organize and modularize code, making it easier to manage, debug, and maintain. Conclusion. Functions are a versatile and powerful concept in mathematics with wide-ranging applications across various disciplines. Whether used to model real-world phenomena, solve equations, analyze data, or design algorithms, functions provide a fundamental framework for understanding and manipulating mathematical relationships. By mastering the concepts and techniques associated with functions, students and professionals can develop a deeper appreciation for the beauty and utility of mathematics in solving complex problems and advancing knowledge.
Don't miss out on our latest content. Please subscribe to our YouTube channel and hit the like button on our videos. Your support helps us create even more amazing content for you. Stay tuned for exciting updates, and thank you for being part of our community.